Hi, my name's Emma Funk, and today I'm going to be talking about an article I read called Muscles, Adaptation to Aging and Training, Architectural Changes, a Randomized Trial. So my email is written down below, ecfunk@clemson.edu, and here's the citation for the article. It was Lido Cart, Adrian J. et al., Muscles, Adaptation to Aging and Training, Architectural Changes, a Randomized Trial, published in BMC Geriatrics, Volume 21, Number 1 in 2021, and there is the date where I retrieved it from. So here again is a screenshot of the front of the article with all the authors, the name, and where it was published. So just to give a little bit of background information on why the study was being conducted, it wanted to look at the effects of aging on contractile protein volume in muscles, which they related to muscle volume, but I'll get into that in a second. So muscle atrophy is a characteristic of aging. That is the loss/deterioration of muscle mass, and it can result in pain, immobility, and decreased quality of life for individuals, but these things can be offset through resistance training. So the purpose of this study, they had two different objectives. The first was to determine if muscle atrophy in older men is a homozygous phenomenon or if it varies throughout different muscles. So basically they were looking at, is the decrease in muscle mass throughout the entire muscle the same, or are there different parts of it that deteriorate faster than other parts? And they did this by looking at the volume of the muscle through the anatomical cross-section analysis to determine the length of the muscle, as well as identifying contractile protein content. And the second part of that was to determine if engaging in higher intensities of training result in larger gains, and for that they're looking at the elderly population, because research suggests that at 60% RPM they reach a max of benefits from resistance training. So they had two groups of 55% RPM and an 80% RPM that they looked into for that. So they recruited for this study 11 recreationally active men, and this group performed exercises at 55% RPM, and they also recruited 11 sedentary older men, and they performed exercises at 55% RPM and 80% RPM. And it was important that they chose sedentary older men to really see the impact that resistance training has, because if they had picked active older men, that might have skewed the results because they would have already had increased contractile protein content and lengthened muscles. So they screened all participants to ensure there was no preconditional health problems, to minimize risk during the experiment, because when you exercise, you always engage in some level of risk. And they assessed the levels of sedentary versus active based on the participants' everyday activities through a survey. So to get into the study design, participants were enrolled in a 12-week training program where screenings were taken before and after the program to assess the change in muscle volume. And they designed the exercises that they did to target specific muscle groups in the legs. So they were looking at the quadriceps, specifically the rectus femoris, the vastus lataris, vastus medius, and vastus animalis, and the triceps surae, which is your calf muscle. And there they looked at the lateral head, medial head, and the soleus. And the exercises they had them perform are listed down below. So a seated calf extension, seated leg extension, and seated leg press. So similar to what we had talked about in class, you can adjust the training intensity and repetitions to get equal training volume, which was important because they were assessing 55% RPM versus 80% RPM, but you want to keep that training volume consistent to get rid of any other biases that would come outside of the intensity of the exercise, because if you're doing exercise at a higher intensity for the same durations as a lower intensity exercise, you're going to get different volumes that you're actually training. So they wanted to make sure that was consistent. So down below you can see the schedule that they had them follow, and you can see that they were having them start at 55 and work their way up to 80 for the top group, because you don't want to start off too strong or else you'll risk injury. And also, like we talked about in class, because they were getting stronger, their RPM was changing. So the RPM was reassessed every 15 days and then adjusted as so to make sure that they were hitting those intensities that were intended in the program. So to break down the training sessions, they lasted 1 hour and consisted of a 10 to 15 minute warm-up on the cycloergometer, and then the defined number of repetitions for the RPM group was built around having a constant volume, and it was assessed by the number of reps times the number of series times the relative load. And they matched for both muscle groups and performed on both sides to prevent any uncomfortableness from only training one leg, even though they only were looking at the right leg. So to measure the results of the study, they looked at muscle dimensions using MRI scans, and the highlighted muscles of interest on each muscle region are identified below. So the results for the anatomical cross-section, they saw that in the vastolaterus, vastointermediate, and vastomedialis, there was no difference in muscles between age groups. So that means that the younger and older saw the same gains in muscle length. However, the rectus femoralis was significantly higher in younger groups, suggesting that that part of the body is easier to train when you're younger. And then for the triceps surae, the LG and soleus had no significant difference like the other groups below, but the MG had significantly higher in younger groups. So here are the relative muscle length curves that were generated from this study. And if you look on the left-hand side on the graph on the bottom for the rectus femoralis muscle, you can see that the old line is slightly lower than the young line, showing that significant difference between the two in terms of anatomical cross-section. So the second thing that they assessed was muscle volume, and that was based on the amount of contractile protein in the muscle. So they found that for the VL, VM, and RMF muscles, they were higher in young groups, where the VI, there was no identified difference between the two groups. And the total volume of contractile protein was much greater in younger groups, where we have the triceps surae, the MG, LG, and solus. They were all higher in the younger groups, so the total volume was much greater in the younger groups. So here we have some graphical representations of the data I just presented earlier, and you can see that for both muscles, there was a difference in the overall contractile protein throughout the entire muscle group, and they were all pretty significantly different except for the vastus intermedius on the quadricep. So the conclusions of this study was that muscle loss with aging is region-specific for some muscles and homogeneous for others. And it was pretty much homogeneous for all of them except at the rectus femoris, which was affected by age at the proximal end of the muscle, as we saw earlier when they presented that the anatomical cross-section was significantly shorter in older populations than young populations. And there was also no difference in training intensities for older groups. So physical exercise at moderate intensity of 55 to 60% of 1 RPM is enough to counteract the age-related loss of muscle mass, but that is without adding additional muscle. So it's not enough if you are older and looking to gain muscle, but it's enough to prevent you from losing it as a result of muscle atrophy with age. So another thing that came out of the study that was important was it was one of the first studies to establish reference curves that can be used to demonstrate the effects of aging. And then these graphs can be used by people in the field and athletic trainers to estimate the muscle volume of an individual within a single scan. So on the left, those are the reference curves that were being discussed earlier that were generated from the study that can be used to assess how much muscle volume an individual would have based on their age. And then on the right, we have some more bar graphs that just show the total volume of contractile protein in each of the muscle groups that were tested. So, how does this study relate to class, and what are some things that were brought up and used in the study that we have learned in lectures so far? So, the first thing that I thought stood out to me from class was how in the study they made sure to adjust the RPM throughout the training program, because when you're following a training program and you're increasing your strength, your RPM is going to change and you're going to be able to lift heavier. So, you need to make sure that you're still lifting at 80% of your maximum rep, and obviously that's going to increase, so that's why they reassess it every 15 days. And also, when they measured muscle volume, they also looked at contractile proteins and contractile protein synthesis, which we had learned earlier. As a result of resistance training, certain chemical pathways are activated, and one of them is the production of contractile proteins that allow us to lift heavier and also increase muscle volume. And that was why they used that as a measurement in their study. And also that age-related muscle atrophy can be offset through resistance training. But something that this study brought up that we hadn't really discussed in class is that different muscles decay in different amounts, and it's not an entire loss of the muscle. But again, from the rectus femoris, we can see that certain regions of it decayed at different rates than other muscles like the vasto intermedius that all decayed uniformly. So also when you are training an individual that may be elderly and their goal is to just maintain their muscle mass, they can participate at moderate intensity exercises of 55 to 60 RPM, and that will help them keep their muscle mass. But if they are looking to see gains, you're going to have to train them at an higher intensity.